Alright, hey everybody. Now we are moving into sensory integration. In other words, we're going to be tying in vision mostly and our sense of vestibulation. So we've already talked about the anatomy of vestibulation. Now we're going to be talking about how it interacts with our ability to see, which impacts how we interact with the world. Okay, so the first bit that I'm going to tell you about is called vection. And vection is a combination of vision and our sense of balance and our sense of movement. And you have probably experienced this before whenever either you're pulling up to a stoplight or whenever you are getting into a parking place. And so for me, the most vivid example is like if you're driving and you are pulling up into a parking spot, and just as you stop in the parking spot, one of the cars to either side of you is starting to back up. Whenever that happens, it's a very strange feeling and it feels like you're still moving, right? Why does that happen? Because even though your body is kind of telling you that you've stopped, your visual cues are telling you that you are still moving. Because after all, parts of your visual field are moving in the same direction that you were in, and it gives you the feeling that you're moving. So this is an illusory sense. In other words, it's an illusion. It's not something that actually occurs, that feeling of movement. It doesn't actually occur, but kind of our eyes play tricks on us. So also, I've felt this several times when I'm at a stoplight. You pull up to a stoplight and you stop right there, and then the car next to you, it may have pulled up too far, but it's decided that it's going to go in reverse now, and it's starting to back up. Whenever you do that, it feels really scary because it feels like you're moving into the intersection, which is horrifying. So it is an illusory sense. And the examples that I just gave you were moving forward and backwards. The same thing is true for rotation. In the textbook, there's an example of an experiment where they had like these circles that were rotating in front of somebody, and then they basically stopped them and kind of moved them, and people felt like they were moving whenever they were standing still. So it's true for linear motion and for angular motion. So that's vection. Also, one other thing is that you see this a lot if you go on Google and you look for, if you go on YouTube and you look for people who are playing like Oculus Rift or playing with like those VR headsets. They'll be like doing something in the virtual world, and then they fall in the virtual world and they fall in real life because they feel like they're moving because their eyes are communicating to them that they are. And so it's kind of this illusory sense. I highly recommend checking that out if you get a chance. The next is going to be both balance and the vestibular ocular reflex. So on one hand, our sense of vision is going to help us maintain balance. So it's not just vestibulation by itself. How do we know this? If you ever try walking on like a thin piece of wood, or if you are on a tightrope or something like that, if you or slack rope or whatever, if you try closing your eyes, it's really, really hard to do that. It's really, really hard to stay completely upright and still whenever and walking whenever you're trying to maintain your balance like that. And it's because our eyes help kind of navigate and tell us which way is up and if we've leaned a little bit too far in either direction. So our sense of balance isn't just vestibular, it is also visual, and that helps communicate with our muscles, with our skeletal carriage that helps us maintain ourselves upright while we are moving. So try it if you have a tightrope, I guess. Close your eyes and try doing it, and it's pretty difficult. The next part is a little bit more confusing. It's the vestibular ocular reflex. And this is kind of this reflexive thing that we have where our eyes are automatically going to move and adjust themselves based on our own rotation. So, for example, if you were to look at, like a word here on the screen, and you were to move your head like that, you can do a pretty good job of focusing on a word, right? Your eyes will automatically move back and forth to make sure that your visual field is clear. But if you were to take if you're watching this on your laptop or your tablet, if you were to shake it like that, then it gets really, really blurry. And so the textbook has this pretty cool example where you can do this with your finger as well. So if you take your finger and you go like that, it looks really, really blurry, right? Even if you're trying to follow it with your eyes. But if you just look at it and then move your head, it looks very clear. So that's the vestibular ocular reflex. And the reason why the vestibular ocular reflex happens is simply because there's very few connections between the parts of our body that are responsible for moving our eyes and for our inner ear. So there's not too many connections. Here you can kind of see the different connections that are made, and I know that looks like a lot, but considering all the other kinds of neurons and nerve connections in our brain, this is actually very, very straightforward. So that's part of the reason why it's reflexive and why we can do it so quickly, because of this direct connection that our inner ear has with our eyes, and particularly the muscles in our eyes. And then we have motion sickness, also called the vestibular autonomic response. And this feeds into this week's discussion question. So why is it that people get motion sick? Why is it that people get seasick? They come from very similar sources. The reason why this happens is because your internal body is telling you that you usually are moving, but your eyes are telling you that you are not moving. So that results in motion sickness. And so if I were to ask you, for those of you that have car sickness, and I know a lot of people do have car sickness, it gets worse as we get older actually, where is the best place to sit in the car to make sure that you don't get motion sick? Most people will say in the driver's seat or in the passenger seat, right? So think about that. If I could, I would ask that you pause this video and think about that. Why is it that people that sit in the back seat get car sick faster than people in the passenger seat? So pause it, think to yourself, write the answer down on a sheet of paper, think for a second. The answer for that is basically, if you're sitting up front, you feel yourself moving, right? Because the car is moving, the car is turning, etc. But if you're sitting up front, can you tell that you're moving? Yes, your eyes are able to see you moving, right? If you're sitting in the back seat, you don't have as much visual information. So basically, if you're sitting in the back seat, your eyes are telling you that you are perfectly still, but your body is kind of telling you that you're moving. And that conflict, basically that kind of mismatching signals makes us ill. It makes us sick. And so if you were to ask somebody who gets car sick easily, do you want to read a book? Do you want to look at your phone while you're riding? No. The answer is absolutely not. Because especially if you're sitting in the back seat and you're reading something, your eyes are looking at something that is not moving, but your body knows that it's moving, especially if you're on like a winding road with lots of turns. So the reason why this makes us sick has to do with kind of our biological background. That if you think about our evolutionary beginnings, think about when would that possibly happen in the wild? When would it be the case that somebody eats I gave it away. When would it be the case that somebody feels like they're moving even though they're not? And the answer is usually when they've been poisoned. And so a very common example for those of you that are over 21, if you drink too much alcohol, what happens? Everything starts feeling like the world is spinning, and you get sick and you throw up, right? The reason why you throw up is because you have indeed been poisoned, and your body's getting rid of that poison. How does your body get rid of poison? By throwing up. And so for car sickness, basically what's happening is that your body thinks that it's sick. Your body thinks that you have ingested something and it needs to expel it, and so it makes you feel nauseated. It makes you throw up. And that's kind of an evolutionary response that we have. So same thing with alcohol poisoning, with car sickness. You get the idea. Relating back to, and you can kind of make the connection with this, with what's going on in this week's discussion. I'm not going to make that connection. You have to make that on your own. Alright, so that's all that I want to talk about for this video. The next video we're going to talk about navigation, which is not something that's really in the book. So I will see you there, and we'll finish this chapter up. Bye.